there's lots of seats. People can sit down if you want, or you can keep drinking and eating if you like. Okay. So, welcome to Cogito's first hosting of the AWS Meetup. My name is Brian Tarbox. You may wonder where Mark Antonati is, the moderator of the group. Well, Mark has become very busy these days, and so he's asked me to step in as co-moderator of the meetup. So, yeah, I'm co-moderator of the meetup. And Mark immediately said, yeah, and I'm not going to be able to make the next couple of meetups. So I definitely walked into that one. A couple of notes. You found the restrooms are down in that side and down in this side. If there's an emergency, follow everyone. Let's see. The next meetup, we have a space available, but we actually don't have presenters, which is a fairly unusual thing. Usually we have presenters and we're looking for a place to hold it, but this time we have the opposite situation. So if you have a talk that you'd like to give, send a note through the meetup to myself and or Mark. It can be a 2-hour talk, it can be a 1-hour talk, it can be a panel discussion like we're having. I don't know that we've ever done lightning talks, but that might be pretty interesting as well. Are you kidding me? Okay. A contractor that I've been trying to get hold of forever. Outstanding. Yeah. I might take the call. Let's see. So we're gonna have announcements. We'll do the first talk. We'll take a little break. We'll do the raffle, and then we'll have the panel discussion. So, are there folks here whose companies are hiring, and you would like to announce that? Oh, and so we have this catch box. So, if you throw it, do not hit the ceiling, because then we're all going to get to evacuate.
Hello, everybody. My name is Jake. This is Kai. We're with Run as Cloud. We're advanced AWS consulting partner. We're looking for pretty much engineers, anyone with some cloud background, just wants to kind of get their hands dirty. Looking for engineers all levels. Anyone else? Hello, everyone. My name is Vivek. I'm with Influence. I'm the SCM team. We work a lot with committees, overall, and lots of kind of, yes. We also have a lot of deployments on AWS, so opportunities, just reach out.
How's it going? I'm Don McKinney. I'm the DevOps team lead at Cloud Health by VMware. We just got acquired by VMware about 5 months ago, and that means we went from being a company of about 300 to a company of 20,000 almost overnight. That means that we're trying to scale up to match. So what do we have roles in? My team does monitoring. My team does infrastructure management. My team does, you name it, we probably get a role for it. We're expanding into multiple offices. We just need more coverage. We have more projects that we want to be able to run in parallel. So if you're looking, feel free to come over and grab me.
Hey everyone. Dave Griggs. I work at the Boston Consulting Group, BCG. Brian, nice to meet you.
Oh, nice to see you.
We're actually hosting the meetup next month.
Oh, yeah.
24th, so hope you all can make it. We're hiring for a number of positions in our proprietary software and tools business. We call it our product business unit. Software engineers, architects, product managers, happy to chat about any and everything. But yeah, feel free to shoot me a connect on LinkedIn, or I'll be around this evening.
There's more over here. Please carry them over the beers. The food we can deal with, but you know.
So before how many of you are really looking for it? Okay, so my name is Jay and I work for Applicant Hub. We have a huge footprint in many platforms. We have multiple openings. Is everything after this meetup? Or more about the job and what type of we're looking for. Either way, we have, also check out the website. You're gonna see a lot more things in there and see if anything that you like. Feel free to apply and show our email. Thanks.
Hi everyone, my name is Avi. I work for a startup called Showed Education, and we're looking for a DevOps engineer. It's a very young startup, and I mean you can get in at the ground if you want to learn about DevOps, containers, Kubernetes, and the rest of it. Reach out to me if you're interested.
Hi, my name is Jocelyn. I work for Tech Systems. It's a recruiting agency, and we have multiple openings at one of our life sciences customers. And they're looking for DevOps engineers, cloud engineers. We have contract and full-time. And we also have another full-time opening with another life sciences client who's looking for more of a systems engineer with some exposure to cloud to get them to be a cloud engineer. So if anyone's interested, please see me after.
My name is Richard Boyd. I work for iRobot. We make the Roomba, a series of vacuums, and the Granda, a series of boxes that are like Roomba. We're looking for, we call them cloud data engineers. It's like a software engineer that like works in the cloud and like it applies software engineering to data. So there's no like special skills you need to be a data engineer as opposed to a regular software engineer. Data scientists, we have like a data internship program for people who graduate from programs like General Assembly or something, if they want to change careers, but life or anything like that. If you like your Roomba and you're looking for a job, like come talk to me and we'll talk.
Okay, and so our VP of Engineering is going to give you some background in the company, but basically we make software that helps you, helps agents who are talking with customers. And we get notifications like extended silence because maybe I was, typing and I didn't realize that I had forgotten to talk to the agent or talk to the customer. So we'll get started in just a minute, but I know it's, it's evening and, maybe we've had a few beers and so we're talking. Oh my God, energy queue. Okay, so it tells me that I have to have some more energy because you guys have to feed off of my energy. And that's what we do. And having stolen all her thunder, now our VP of Engineering.
Hi, I'm Margaret Olson. As Brian was saying, I run engineering here at Cogito. Those cues normally come out in a little coaching app. I like to say that we do real time because you hear all the time that people say, oh, it's real time. And I'm like, well, yeah, a couple seconds. That's not real time. If you're coaching somebody's conversation, you have 250 to 300 milliseconds to get that audio from the customer's on-premise phone up to AWS through our compute engine where we have the AI algorithms based on machine learning, calculate the cues and get it back to the agent. So there's a whole piece to our system that we call the real-time system. And then, of course, there's all the reporting that helps the supervisors and managers understand what's happening in the application. Myself, this is, I guess, my third startup. My first one was Constant Contact. My second was bought by Nokia. Here I am. I started using AWS, I think in 2007. I know that the first time I saw it, I thought, you have to do an awful lot of work to like string something basic together. But as we all know, AWS just kept pumping things out. And the first service I used was S3, and I think it was in 2007. I've never looked back since. So I'm a big fan. And of course, we are hiring. We are hiring regular software engineers, data people to deal with the massive amount of data that we generate, both the calls and the content of the calls, machine learning, web, telephony. We're growing like crazy, so we are hiring. There are hiring managers here, and I'm going to ask you to stand up or wave your hands or somehow make yourselves known. If you would like any information, talk to one of them. We also have a table around the corner, which the recruiting team wants me to point out to you, the table around the corner. And of course, you can always just send an email to me, Molson, like the beer, Molson makes it golden, easy to remember, at cogitocorp.com. And Brian, over to you.
Right, send it to me because then I get the bonus. Look, it's all about promotion. Okay, excellent. So let's get started. So I'm going to introduce the first speaker. Is going to be talking about Lambdas. The speaker is awesome. One of the best speakers you'll ever hear. It's me. It's all about branding, man. So yeah, I've been writing in Amazon for 6 or 7 years now. Got some certifications. I did some talking at Java 1 back when Java 1 mattered. I have an open source project that turns log files into music, so you can listen to your log files, which is kind of crazy. And there we go. So let's dive in. So we're going to talk about Lambdas in general. I know for some of you, probably know all kinds of stuff about Lambdas. For others, it's an introduction. So we're going to do the backup, get a running start. We're going to show some Lambdas. We're going to show you various ways to create Lambdas. We're going to look at custom resources, which is an interesting thing you can do with Lambdas. We'll do a little bit, I'm sorry, but just a little bit with SAM wrappers. SAM is a whole nother topic that deserves a whole nother talk. If someone wants to give that talk, please talk to us. Talking about logs, configurations, and then layers. So, and please jump in if you have questions and so on, and then I'll throw the box at you. To you, sorry. So Lambdas were introduced back in 2014, and I remember hanging out with my buddies at the time saying, I bet in 5 years we're going to look back and say, hey, remember when we needed computers, okay? And we're getting there. We're basically getting there. At this point, everything that I write is serverless. I like to say I haven't drunk the Kool-Aid. I have waterboarded the Kool-Aid of serverless. And I want that phrase to go viral. And some folks say, well, Brian, there are servers underneath serverless. I mean, it's not running in thin air. Yeah, but I don't care. And y'all don't have to care. He's from Amazon. They're his problem. And originally, Lambdas had all kinds of limits. They were, 5 minutes. You only a couple OSs runtimes that you could use. Every year, Amazon increases the number of runtimes. And just as the last reInvent, they added the ability to bring your own runtime so you can do anything you want. Back in the day, I was a Prolog programmer. I really want to write a Prolog Lambda because I think that would just be so insanely cool and useless, but it would be cool. And now you can have Lambdas that run for 15 minutes, and you can debate whether that's a good thing or not. It's sort of like virtual memory. I mean, I remember, back in the day, I remember before there was virtual memory, you wrote type code, and now you don't have to. A Lambda that runs for 15 minutes, maybe that should be a step function. Maybe that should be something else. I mean, I think it's great that Amazon is giving us this choice, but Amazon gives us incredible number of choices. It's 150, 160, whatever services. Which one do I use? I don't know. Other cloud vendors have similar offerings. I'll say in the past, I've done some Azure work and some GCP work. I don't know how to do a moderately horrified face, but so they do. So Amazon isn't the only ones doing it. They're the only ones doing it right. I'm not opinionated. So what's a Lambda? So Lambda is just basically a lump of code that gets triggered and then does something. So you have, and I had a laser pointer, but I discovered laser pointers work everywhere except on the screen, which is just sort of crazy. It's a flaw in the technology. But you have all kinds of things in your Amazon environment that can cause events to trigger. The typical one, the sort of standard boring one is, oh, I put a file on S3, it created an event. But there are all kinds of things that can create events. It then invokes your function. Your function can be in any one of these runtimes. It's probably a good idea to standardize on one. I've worked at places where, I worked at one place where they said, every developer can write in whatever language they want. Isn't that cool? Yeah, no, don't do that. Pick a runtime. And then your Lambda can do something. And when we first start playing with Lambdas, we think, okay, a Lambda has to do something self-contained. And then there comes a time when you say, Bodo, I could call other Amazon services. I could do anything I want. And then you realize, I could do anything I want, including call other Lambdas, which call other Lambdas. And, again, maybe that should be a step function, but, different strokes. But that's the gist of it. You have a trigger, you have a lump of code, and it does something, and the something can be anything you want. So what can trigger a Lambda? This list is one of these wonderful lists that gets obsolete all the time because Amazon will keep adding more. And I will say, this slide annoys me because I spent so much time trying to make the damn bullet sizes even. Google Slides, you failed me, man. So anyway, so you can trigger a Lambda from all kinds of things. One of the interesting places you can trigger a Lambda from is from a CloudWatch event, and that's how you get cron. So you can have CloudWatch events that are set on a schedule that can happen whenever you want and can trigger a Lambda. So basically, that's how we get scheduled Lambdas. Okay, S3 is the standard one, but you can do all kinds of you have all kinds of triggers, and they're going to keep adding more. So it's as if they had an ecosystem. Okay, Lambdas can be as simple as you want, or to some degree as complex as you want. They all have a handler function. That's what gets invoked by the trigger. And then it gets an event object, which is the data you're sending to your function. When you're calling a function, you pass it parameters. And then the context object that tells you information about, go figure, the context. I love simple names, predictive names. The context is the context, the event is the event. So you can have a simple function like this that does nothing but echo back the information it got. And that's a great place to start. Or you can go sort of nuts. And I don't expect you to read this. Actually, this is some of my Alexa Node code, and I'm not a Node programmer. I just try to write in different languages, so don't read this. It's probably terrible Node. But you can do all kinds of stuff. You can set variables, you have functions. I'll jump ahead. This Alexa skill actually is for British Premier League soccer, where if you're a soccer fan, I invite you to ask Alexa to open Premier League. And there are no Alexas around, so I get away with saying that. At home, we call her Amanda when we're talking about her. But you can have little functions like touches. How many touches did the player get? How many fouls did the player have? How many tackles? Sort of doesn't matter, but the takeaway is this function is 600 lines and has 47 functions in it. Now, you can debate, is that good or bad? And how big a function do you want to write? And how maybe you should split it up. Oh, with layers. Oh. And I would probably rewrite this in layers. But the point is, most of the tutorials show us tiny little Lambdas. I'm just saying they don't have to be tiny. They can be as complex as you want. Okay, so great. How do I create a Lambda? Well, there's a lot of different ways to create it. You can edit it directly in the GUI. You can create it right there. My DevOps friends, and I'm a DevOpsy guy, says, oh, that's terrible. That's the devil. You can't use the GUI to do anything. Everything has to be command line and functions that you can check into Git. And it's like, yeah, but I got a prototype, man. So the GUI is not so terrible. You can code up the function inside CloudWatch. You can actually have the body of the Lambda inside CloudWatch, and I'll show you how to do that. And again, some people say, oh my God, that's horrible. And maybe it mostly is, but there's times when it's really a pretty cool thing to do. Or you can package your Lambda code up into a zip and get the zip file up to S3 and then deploy it from a variety of ways. You can do it from the CLI, you can use SIM, you can use CloudFormation. There's all kinds of ways to get your code up there. So here's how you create it through the GUI. And actually, if my thing has not timed out, instead I'll show you. This is sort of the live GUI. So hey, Boston AWS Meetup, yay! So I created in the console. I created a Lambda. Over here you have. I gave the Lambda an IAM role, which gives us the ability to talk to other resources. These are the things it can talk to. I can add triggers from over here that will fire the Lambda. You can see right now I have no layers. We'll get to that in a little bit. And then you have your code, and you can just write the code right here, and then you can create a test event, and then you can run it. So for experimentation, this is actually a pretty cool place to be. People always say with DevOps, you have to automate everything immediately. And I say, automate it second. Do your experimenting, figure out what you're doing, and then automate it. But you don't have to automate it immediately. So that's kind of cool, I think. Again, there's all, your mileage may vary. If you hate GUIs, carry on, Okay. Okay, yeah, small functions, it's cool. Okay. So this is the thing that I think a lot of people don't know. You can put the Lambda right in your CloudFormation template. So this is, see if this mouse showing up. Okay, yeah. So this is a CloudFormation resource. It's of type Lambda. It has properties like what function am I going to, what function within the Lambda am I going to call, the name of the function, the role, and so on, and then code, and then zip file. And normally right here you'd put a URL, but you can also just put the little bar and write the code right here. Now you might say, but I shouldn't put code in CloudFormation. CloudFormation is deployment configuration. But haven't we been having it beat over our head that everything's code and everything's checked in, and deployment is code and configuration is code? So I think writing a Lambda right inside your CloudFormation template for a small thing is actually pretty useful. And here's part of the reason why. I'm a big believer in the old literate programming notion from Nicholas Wirth, probably no one remembers who that was, where you should be able to figure out what things are from the name. But sometimes you need a little bit more information than the name. And if you do the standard Lambda deployment where you're going to an S3 bucket inside your CloudFormation template, and you have other things inside your template that are using that Lambda, you have to either know from the name exactly what it does, or you have to go open another file, find it, hope it's not another repo, another branch, have to find it and go see what it does. For a small Lambda, if it's all right here, it's all right here. Again, you don't have to agree with me. Okay, custom, and I guess.
The size of the Lambda has to be smaller than 4,000 characters.
Yes.
Yes, just so it has to be small.
Right, which is great. That's a great limit. Don't write, I'm going to contradict myself a bunch, but that's okay. I'm a developer. I don't have to make sense. As I said, make your Lambdas as big as you want, except when you shouldn't. For Lambdas like this, you are limited. And if you're making Lambdas that's more than 4,000 characters, maybe it's not such a little thing that it should be in here. So I think that's an awesome limit. Please don't fix that. Okay, custom resources. CloudFormation is basically how we do DevOps here. Some people use Terraform, but we use CloudFormation. And so we use that to create all our resources. Amazon does a great job of keeping CloudFormation up to date with all the other services. But the services come so quickly that Amazon doesn't always have immediate availability of all the resources, or necessarily immediate availability of all the parameters for all the resources. They do a very, very good job. But there's times when you can't wait for them. There's also some things that you just can't do inside a standard resource. So for example, and I'm sure you'll have announced the service since last time I checked this and tell me I'm wrong, but that's okay. You create a database, you can create a database resource in CloudFormation, but I'm pretty sure you can't create tables and stuff. You can't do DML stuff inside the CloudFormation template. So for that, if you want your deployment to include creation of the tables, which you can argue whether that's a good idea. But if you want to do that, you need to essentially shell out. And custom resources are how you shell out. So this is a custom resource. It's of type custom, okay? It has properties service token, and it gets the ARN of a custom Lambda. Oh, look, we have the custom Lambda over here. And it's, well, of course, it's a Lambda, and it has the handler, the roles, and all that. And here I'm using the other style of deployment where I'm just referring to an S3 bucket. When this resource gets instantiated by CloudFormation, what it does is call the Lambda and passes it a create. When you update this resource in CloudFormation, it sends an update message to the Lambda. And guess what happens on delete? So you can, using this, you can do anything as part of the creation of one of your resources. And that can be a really cool way out of any restriction you might feel that Amazon is giving you. There's yin and yang. Custom resources can be tricky, as I discovered one Saturday where I spent about 8 hours on the phone with Amazon support. Amazon support is great, by the way. If you have it, use it. It's not the cheapest thing in the world, but if you have the enterprise support, man, you should be talking to them every day. And you've already paid for it. So the trick with custom resources is you have this handler, okay? And in the end, you send a CFN response. And you better send a CFN response no matter what. If you don't, your Lambda will hang and your CloudFormation will hang. How long do you think you hang for? 4 hours. And there is nothing you can do to stop it. And there's nothing Amazon, even with enterprise support, can do. You are stuck. Use your try blocks. It's very, very cool, but you know, there's some downsides. Okay. You can also okay, switching gears. Okay, other ways to deploy Lambdas. You can use a SAM template. Now, SAM, as I said, is a whole thing that I don't want to get into. I can't really get into tonight. But you know, SAM is basically when you're having a bunch of resources, maybe multiple Lambdas, and so on. But you can also use it in sort of a degenerate case of one Lambda, and there's times when that's really very, very handy. And so, in this case, this is a full template. I've got a file index.py that lives in this directory, and I've got some CloudFormation SAM commands that will take care of everything I need to build and deploy this. So this is kind of cool. So SAM, at a certain level, is just a wrapper around CloudFormation. So SAM package, which is the same thing as CloudFormation package, you run it in the where that template file lived and where your index.py lives, call it whatever. And it creates a zip and it copies it to a location in S3. Then you do SAM deploy, CloudFormation deploy. It deploys the Lambdas that were in that zip, to your system. So if you want to get away from writing a Python file, manually zipping it, manually copying it to S3, manually doing a deploy, this is the way that you can script it and automate it, even just for one Lambda. And it gets you a little bit exposed to SAM. At that point, you can say, "Oh, I'm a SAM developer. This is awesome," and then move on down the line. Serious? Okay. Okay. I just want to. Did I? Okay. Oh, I did. Okay. I put all this work into animation and then I screw it up. It's a great way to deploy single Lambdas and step functions. Step functions, you say? So, okay. Hey, if that's the worst screw up I do, I'll take that. Thank you, demo gods. So step functions were introduced in 2016. And back then I wrote for this online magazine called Search AWS, which they went to great pains to say they weren't associated with Amazon, but we wrote all about Amazon. And we'd do reviews of what were the cool things coming out of reInvent. And in 2016, I thought step functions were the sleeper hit. And they slept for 2016. and they slept for 2017, and now they're getting a little bit more love, and I think they're pretty cool. They're basically an orchestration framework, a way to have a bunch of your Lambdas tied together and work together and handle errors and choices and all kinds of things. Since 2016, SAM and Lambda applications have come on the scene, and there's a lot of overlap between them. And there are folks who say, oh, step functions didn't work. They got superseded. You know, they're going to go away. Other people say, no, step functions are going to take over, and SAM is going to be this passing fad. No one actually says that, but you know, it could happen. Geez, I thought that would get laughed. Oh well. Thank you. Pity laugh. Thank you. And the idea is step functions think flowcharts for Lambdas. And for any of you all who are too young to know what flowcharts are, that's what a flowchart looks like. So basically, it's just you have a start state, you have a bottom state, and you follow the arrows and do decisions and choices, and you get to the end state. Okay. So this is the step function that I wrote. And basically, it starts at the top at start, crazy enough. And actually one more little animation. Okay, so random 1 and random 2 are Lambdas, and pick the bigger value as a Lambda. So what this step function does is it starts in parallel. It calls this Lambda twice, and these are the tiniest little Lambdas. It just does a random number, and then when both branches are done, it comes to this choice state. And the choice state has a little bit of logic. It says if the first random, the random number is 1 to 100 or something. If this one says if the random number is less than 10, go here to this wait 5 seconds rule. If the second number was less than 10, go to this 5-second rule. If neither one was, go to this little Lambda, which is another little trivial one-line Lambda that that says which one is bigger. And then it goes down here. We configure a count. We go through an iterator. The iterator does nothing, but it could. And then it publishes to SNS. And the cool thing is that originally step functions could only call Lambdas, but at reInvent 2018, they added some other things you could do directly in a step function, which gives me hope that their step functions aren't dead-ended, that they can continue to do things. So this is sort of a silly example. It doesn't really do anything. But it shows you a bunch of things you could do with Lambdas. With step functions. One of the cool things with step functions is it shows you what actually happened. So, the one on the left worked, the one on the right didn't work. Anyone have trouble figuring out where the one on the right failed? The red box. Oh my gosh, So it's really very easy to tell. And while the step function is running, you can see the colors changing as it's going, so you can see what's happening. So I find this actually quite compelling. Yes.
What exactly is the trigger to start the step function?
Okay. Well, in my case, I just triggered it from the GUI because I was just messing around. But you can invoke a step. A step function can be invoked just from from a Lambda, from any code you want. It's just it's just like another service.
Okay, but can it be triggered using like S3 events and API gateway or something like that?
API gateway can do S3 events, can't do directly. You can Lambda to take on the S3 event and turn that into an application.
Right. Yeah, it would be nifty if you could have all Lambda events also be able to trigger a step function. But right now they trigger Lambdas, and you have just a little Lambda that triggers the step function. Okay. Okay. No, come back. Okay. You can also in the step function GUI, you can see everything that happened. So each of these steps shows you what was happening. So I started the execution. I entered the parallel state. Oh, look at the parallel state took 23 milliseconds. And then it called random. And for some reason, random took 124 milliseconds for this one-line Python script to run. We'll get to that in just a sec. And then we actually scheduled a Lambda. And look right here, you can look at the CloudWatch logs. So it's all very tightly integrated. It's actually pretty cool. Okay. So what can you do in a step function? Well, you've got these states. these states are sort of hard-coded things. So passes, fails. It's this, stop state. And you can have wait states. So has anyone ever written a Lambda and put a sleep inside your Lambda? Yeah, I know some people who aren't raising their hands, but that's okay. I'm not going to call them out. You can do that, but don't do that because you're paying for it. Do a wait state which you don't get charged for. Okay. Then you also have the task state, which actually does some work, and then choice states, which make decisions, and then parallel, which lets you do things in parallel. I love these names that are just so predictable. What does the parallel thing do? It's parallel. And so a task, what are the tasks? Originally with step functions, the task was just a Lambda. But now you can also run batch jobs. It's like batch jobs. I remember when batch was cool in 1977, and now batch is cool again. That's really weird. You can talk to Dynamo. That's cool. You can run an ECS task. Now we're talking. That's kind of interesting. Publish SNS or SQS, or you can talk to Glue. Glue, again, when I heard that, I thought, you're just making this stuff up. Y'all have just run out of names. I actually have not played with Glue, or SageMaker. And you can imagine it as an AI company or data science. Sometimes we get yelled at for saying AI, data science. SageMaker, kind of interesting. And I expect this list to expand, okay? Of course, since you can since you can call a Lambda and a Lambda can do anything, you can already do anything, but just making it simpler. Okay, some folks say, okay, Lambdas and serverless are great, but there's simply no way to monitor them. There's no way to look at the logs. There's no way to debug them. Obviously, I don't agree with that. Is it different? Sure. Is it harder? Anything new is hard for a while. Okay. So this is monitoring right from the Lambda page over the last 12 months. How many times did we invoke some particular Lambda? Gosh, for a while there, we were invoking it a lot. You can look at the duration, min, max, and average. Over here, you can look at success and error counts. You should really occasionally come and look at your error count. It can be higher than you thought. When I write Alexa skills on the side, and I have Lambdas, and I was sort of shocked at one point to go and look at that some of my Lambdas for my Alexa skill were failing. I'm sure people were upset at that, and hopefully were yelling at Alexa, not me. So. But so you can do this all right here, and you can view the logs in CloudWatch. Here's an example of a log. One of the things that is so obvious that no one states it, so it can take a while to figure out, because it's so obvious that why would anyone tell you, is that the CloudWatch logs for Lambda live in. You go to CloudWatch and go /AWS/Lambda/ the name of your Lambda. It's so obvious, but I'm ashamed to say how long it took me to figure that out, because it doesn't say anyplace. And then you can look at all the logs, and that's really handy. So the logs are right there. And then, if you're you can do log aggregation and Sumo and Splunk and all that stuff. But that's another whole talk that someone should give. Okay, Lambda performance. So we're not supposed to know this, or maybe now we're allowed to know this, but we weren't. Amazon is very cagey about how anything actually works. But whether they meant to or not, they sort of let the cat out of the bag that Lambdas actually run in containers. So it's all Docker. And containers have life cycles. If a container is up, the first time you run your Lambda, there's a cold start. It takes a little while for it to load up. After that, it goes much faster. So if cold start becomes a problem for you, and you remember we saw that my little one-line Lambda took 124 milliseconds, that was probably a cold start. If I ran it again, it would probably go much faster. Let's assume that I ran the test. Yes, I ran the experiment, and it ran much faster the second time. So what some companies will do, if cold start isn't an acceptable situation for them, they'll have a croned CloudWatch event trigger for their Lambda that basically does nothing but cause the Lambda to stay to stay in container, I guess is the term. So And as you get, if you have one Lambda, that's fine. If you have a whole sea of Lambdas, then it can get interesting. How do you want to trigger, a keep me in memory, keep all my containers in memory, but don't really do anything. I don't want to get charged for it. I don't want to actually have it do anything. And if you got a whole bunch of Lambdas, that might be tricky. That actually might be an interesting case by itself for a step function, a keep alive step function. Ooh, I see a paper. Okay, so how do I make my Lambda go faster? How can it run? How am I charged? And concurrency limits. Okay, so your Lambda runs, you don't have direct control over how much CPU your Lambda gets, but you control that indirectly by this slider over here. By default, your Lambda gets 128 meg of memory and a certain amount of CPU. If you want more CPU, give it more memory. By giving it more memory, you get a faster CPU. And there are thresholds and limits where if you get to amount of memory, you get instance type equivalence CPU. I don't remember. I drag the slider until it goes fast enough. And you get charged more if you are looking for bigger instance types. So don't just pull it all the way over here because you'll get charged more for that. The timeout, this particular Lambda set, it can run for 1.5 minutes. Again, I've seen people say, well, Lambdas can run for 15 minutes. I'm just going to set it for 15 minutes, even though mine only runs for 30 seconds. But we actually talked about this at Serverless Days 2 weeks ago, and that's actually a potential security hole. If your Lambda shouldn't be running for more than 30 seconds, and you let it run for 15 minutes, what do you think it's doing for all that time? Probably no good, We haven't really seen Lambda exploits yet, but at some point we will. Give your Lambda the amount of time it probably needs, plus a little bit of a buffer, but not a lot more. Okay, concurrency. By default, you can run 1,000 Lambda executions at a time. And for most people, it's like, oh my God, that's crazy. I couldn't possibly need that until you do. And so we actually use Lambdas enough that we've run out of Lambda concurrency. And so what you can do, you can reserve some concurrency. So this particular function, we decided, well, it was my function, so I decided that I did not want to be bumped. So I said, I'm going to grab 5 units of concurrency, and the rest of the Cogito can fight over the 995. I'm getting what I want. And so you can do this to balance out, to make sure you don't get, that your Lambda doesn't get blocked by a bunch of someone else's Lambdas running. Okay. Last topic, layers. Layers are so cool. I know I've said that a bunch of times. And in reInvent 2018, they introduced Lambda layers. You get the sense that you should really go to reInvent and hang out with 65,000 of your closest friends. Every year reInvent seems to double in size, and last year was kind of, this year they seem to really, a bunch of us went and they really handled it. So layers are cooler than you might think. So basically layers are, you can package up code that then is attached to your Lambda and runs together. And when I first heard about Lambdas or layers and I started playing with it, I was like, okay, it's sort of like a library. I can write some common functions that I might use in a bunch of different Lambdas, and I'll stick them in a library, and then we'll call it a layer, and we pull it in. It's like, okay, and that's true, and you can do that, but you can do so much more, and we'll get to that in a sec. So it's more than just the code packaging and reuse. There's also this notion of custom runtime. So one way to think about Lambdas is, I think it's conceptually similar to Docker layers. If you're familiar with Docker, if you look at your Docker file, you start from a base image, and then you do some stuff and it creates a Docker layer. And then you do some more stuff and it creates a Docker layer. And it's additive. And if you replace something in a previous layer, well, it's replaced. But you end up with this stack. And Lambda layers, in my mind, are very similar to that. Amazon has given us the ability to replace the base layer. So if you want to write a Lambda in Fortran or Prolog or some crazy thing like that, write your own runtime. And I haven't explored that yet, but it's pretty well documented. You know, there's standard API you have to follow, but you can create a runtime to do anything you want and then put your own code on top of that. Okay, and so you create a layer and then you attach that to your regular Lambda that's going to use it, and then you just run it. Yeah, package up code reuse, blah blah blah. One of the things, if you are using it just as a library and you're pulling code out into a shared area, the code that you're deploying is smaller. And since there is a limit to how big a piece of code you can edit in the GUI, if you care about that, this lets you get bigger Lambdas editable in the GUI, but it also makes more decoupled deployments because you're not changing the piece underneath, and probably faster as well. One thing that's kind of interesting to me is the layers cannot be themselves written. The code for the Lambdas for the layers can't be written in the GUI. I mean, you set them up, but you can't write them in the GUI. You have to edit them outside and upload them. Okay, so how do you do it? It's shockingly easy. You create the layer, you zip it, you upload it. Okay, so here's a layer function. You know, it says, "Hi, I'm running inside a layer." Dead simple. You go over here to the create layer part when you're creating a function, and if it works, I'll jump over and show you that. But you say, I'm not creating a Lambda function, I'm creating a Lambda layer. And you give it a name, and you upload a zip file, and you say what runtime you want. And now you have a layer, okay? A layer is available. Then you create a function that uses the layer. And so you import the layer function as layer function, and then you just call it. And when this code runs, you know, it'll say, hey, I'm inside the layer, and then it'll say, hey, I'm inside the Lambda that uses the layer. And it's as simple as that. Now, a thing that's kind of a little mind-bending about Lambda layers is it gives you a file system, which is sort of weird to me because Lambdas, it's serverless. There's no server. You don't have access to a file system, except with layers you do. The layer is just essentially a zip that gets exploded into essentially a virtual directory. So any Python layer gets expanded into /op/Python. And then you have the file system. Then you can do anything you want. There's probably some limits. And one of my buddies said, how big a disk is it? And it's like, I don't know. Let me find out. So I got to do that next. Oh, sorry. And I'm jumping ahead. Yes, so you have a Lambda with a layer, and you attach the layer here, and you add the layer here. I mean, there are tutorials. This is really dead simple. And the other part is more exciting. So you can add data files. You can add data files to your Lambda. Add the data file to your zip and process that data in your Lambda. You can put executables in your Lambda, in your layer. And then you can have your Lambda shell out and call those executables. No security holes there. Nothing bad could happen there. It just strikes me as pretty amazing. So like right here, I've got this little function. It imports the layer function. It imports OS. And this is probably horrible Python, but I write all in YAML anyway, so these days. So you have a path. That's where my all my layer stuff lives. I grab some data file, I open it, I print it, and I've talked in a Lambda to a data file that lives in it. Yeah.
Is Lambda layer available globally, or is it specific to a region where you upload your data?
Yes, it's just in the region of that account. Sorry, it's just a little echo there. Yeah. So it's sort of mind-bending to me that the Lambda layer gives you a file system. I want to explore that some more. So anyway, that's layers. Yeah. And So that's it, except I want to say these are the things we didn't get to. There's Lambda applications. We really didn't do much but scratch the surface of SAM, and there's probably all kinds of other things I can say about Lambda, but that's all we have time for. So, okay. Okay, so we're going to take just a very quick break. We're going to do the raffle, and then we're going to have the panelists come up. The panelists, well, I'm going to have them in. Cool folks, cool companies. We did good. I'm going to have them introduce themselves, and basically the topic is, so EC2, ECS, Fargate, Batch, Glue, what should I be doing, and under what conditions? And you know, we hope we have a nice spirited debate, and we're going to do the raffle now. And the panelists can come on up.
All right. There you go.
And which one is this for?
All right. What do you think that says? Is there a Nese? N-E-S-E? N-E-S-E? Is that someone's first name? Am I pronouncing? Nese? No? Nese? No?
Okay, is someone here from DOD named Nese? N-E-S-E? From DOD? Going once. Going all 3 times. Okay.
Try again. Victor Chan? Victor Chan?
This is a raffle. Guys.
Free stuff, no?
Free stuff.
Victor Chan?
Victor, are you here?
Victor,
Victor. Victor.
Get rid of the names.
Okay.
no Victor.
Okay.
All right.
I actually see them.
Dave Griggs?
Dave Gray.
Dave
All
Grant.
right.
Is that for the dog?
You can go see Derek for your prize.
Right on the corner.
Oh, we got Victor? Okay, Victor, see Derek for your prize. With one more. All right.
All right, cool.
Roosevelt Segura. All right. Thanks for coming.
Hey, thank you.
The flow chart for the step function.
Yep.
Are you able to edit that, or is it done just? Can you drag those boxes around?
No, the UI is not that flexible. You actually write stuff in JSON and then upload it in the Amazon show to it.
Because they're inclined to be of server integration services.
Right.
It's almost there. I think that's
what
the piece
they're
that they're missing. That's the process they're missing.
And then the other question happens: do you have a sample of what sounds like? Curious.
Go to briantarbox.org, my website, and then it'll
Take a picture of his previous slide.
yeah,
There you go.
briantarbox.org, and on the sidebar it'll lead you to it. Cool.
Thank you. We're not going to be here.
No, but oh, that would be, yeah. That would be awesome.
Cogito.
I look forward to this. It's gonna be awesome.
Make the announcement. He will ring the bell. All right. So let's get ready for the next session. My name is Mauri Niininen, and I will be the facilitator for the panel discussion here. Do we have the names of the people? I think.
Last slide.
Last slide. Okay.
Yep.
So let's put this up. Where is it? Where is it? Full screen. Nope. Where do we have
What do you
the
want?
present? Where's the button? There we go. All right. Thanks.
Okay. And let me.
All right. So we have the panel members here. We have Hera Sharma from Cogito. We have Don Lucchini from Cloud Health. We have Tim Harney from Amazon. And we have Richard Boyd from iRobot. And I have some warm-up questions here. I hope that most of the questions come from the audience. And we have this
Brian took it
over there.
Table over there.
Yeah, so we'll throw this and please state your questions over there. And we have about, how many minutes? About 40 or so? About 40 minutes, so let's hope that we have interesting discussion here. All right, so as a warm-up, we talked about serverless here. Great new functionality, you know, Lambdas, step functions, SAMs, all nice and dandy. I'm from cloud operations, so I'm responsible for making sure that these things actually stay up. So my first question is, and this is coming from the idea that we've heard, at least from the marketing speak, that these serverless functions, they're infinitely scalable. So how would you measure performance and do performance testing when using these kind of serverless systems?
Yes, they're infinitely scalable, which means that when things go wrong, they go wrong very quickly, and they get expensive very fast. Think about AWS has a lot of built-in soft limits, 1,000 concurrent Lambda executions. You'd be surprised how quickly you can reach 1,000 with the bug in your code, and then you're just burning through money. So it requires a lot of people to rethink how they do metrics instead of just how many servers do we have up, what's the CPU utilization. You start thinking about like latency per request size, or you try to normalize the metrics based on the volume of requests that you're seeing, so that if you're suddenly taking twice as long to process the same amount of data, that you see those in the metrics.
I think just to add to that, to your point about testing, I know Brian mentioned it earlier, with SAM and the SAM scale lab being able to execute Lambdas locally to run through some of your testing before you get into any of those limit situations when you're executing on the cloud. Also being able to execute step functions locally, like step functions local is a big tool that developers can use so that you can execute your entire environment, test it out, make sure that there aren't those massive bugs in your code that are going to run beyond your scale. And then working with CloudWatch or any of our partner tools like Thundra or Datadog to actually monitor your Lambda invocations and apply some intelligence around those metrics that we were just talking about to give you that insight. What's the request latency? When do we think we're going to scale raise our limit, because maybe you raise that soft limit to a new number based on your new normal, but to kind of increase that every 6 months your application skills.
I think the question that I would ask is, why is that any different than monitoring any other microservice? The architecture that we've got is more or less external to us as far as monitoring goes. If you look at our monitoring stack, we're using New Relic, we're using Datadog. Those are tools that don't really care if I'm deployed as maybe I'm a Ruby on Rails app and I'm a monolith deployed on EC2. Maybe I'm microservices with a static UI in S3. Maybe the microservices are deployed in Kubernetes, and maybe I have a database in RDS. New Relic doesn't care. New Relic is going to spit back numbers at me that are really irrelevant as far as the underlying architecture is concerned. What will change? How do I trace my application? What will change? How do I make sure that the one little piece over here, which is now one little piece and not a function in a monolith, what happens when that breaks? I have to start thinking about disaster recovery. I have to start thinking about graceful degradation in a much higher fidelity way than I would otherwise. Those are the sorts of things that change for me.
Yeah, no, I think that I definitely agree with that. When you are still looking at your application and you have you break it down into a number of different functions that you run as a serverless Lambdas. Lambdas has a very different way of looking at the performance metrics. In a typical application, you look at CPU, memory utilization, you look at the disk, you look at all these different things, and you see how the CPU has gone up and how my memory is doing. None of that is actually relevant when you're looking at some of the serverless application. You give it a memory, and that's what you are looking at, how your latency is doing. So latency is definitely a key metric that you want to track on how your application is doing and how you're using the memory. To another point about what Don was saying around looking at the applications and looking at the flow. That is a key thing. When you break a big monolithic application or break a microservice and nanoservices, like function as a service, it is very hard to figure out how one service calls the other service and where your latency is. So X-ray, I think, is one of the things that I was hoping somebody would mention. But that's one of the things that you should definitely look at if you haven't explored that. It gives you a service map, but also gives you different latency metrics. Can be a very good tool when you're doing your performance testing as well.
Okay, thank you. Any questions from the audience?
I just had a quick follow-up for it.
Absolutely. Yeah.
I absolutely agree with you're starting to track latency, and we aren't tracking memory very much. And I think this comes back to just serverless in general, that like a customer doesn't care what your memory consumption is. Like if you say, oh, we're going to serve the same request with 10% less memory, find a customer who will pay more for that and solve a bridge, right? Like, I think that this is along with the bigger theme, like serverless allows you to focus on your business metrics. So you can focus on latency, that's what your customers care about. You can focus on like requests per second that you can get through the system, peak volume, things like that. I think that because of this, because I don't have to care about memory and CPU utilization, I can focus on the things that I actually care about as the business owner.
Absolutely, definitely. Yeah, honestly, something that even in the server world that we can architect for is resiliency. That's something we at Cloud Health continue to have a pretty big install that's running on EC2 Bear. And the way that we deploy that is highly redundant. What that enables us to do is, let's say that, sort of to your point earlier, you're looking at metrics like CPU, memory, disk. I don't look at disk. I look at disk in aggregate of a system, but not on an individual server. If an individual server is up at, I think our threshold is 97% disk, we shoot it in the head. And our automation does that. We don't even know unless, I think, 5 of them get shot in the head in 30 minutes, and then we've got a problem. But ultimately, the infrastructure and the automation is doing that for me.
Yeah, and I think, again, as you start your serverless journey, you're going to go through different levels of maturity. And as you mature, a lot of your focus will shift from some of the typical metrics to a much more business-focused metrics. And I think that's what we're seeing.
So question over there.
Catch it.
So I think with serverless, you're not making tons of decisions, but you have to decide for Lambda how much memory you're going to give it. I think that is, so the cost is a function of, runtime, the actual running time, the memory it takes, which means that a piece of Python code, an individual piece of memory goes faster.
the less memory, it costs less, but it runs slower. So you have to really make that decision in piece of code what's optimal memory needs.
Yeah.
So how are you going to put aside that for the values? Any thoughts on that?
That is a dark art, because I've seen examples where code will, turn all the way down to 128 megs. Ideally, that should be cheapest. But if you give it a little bit of extra memory, it'll run faster, and the speed improvement is greater than the extra memory you have to pay for. So it actually finishes faster proportionally to the amount you're spending. And if you save money, if you keep going, your overkill on that, like whatever the bottleneck was, you're over provisioned for, you end up spending more money. And that's moving the slider and testing, and having a really good understanding. Just because it's serverless doesn't mean we suddenly stop worrying about how our code is performing. I think this comes back to like it's hard to like load test a lot of these. Like, we talk about infinitely scalable services. How do you load test Lambda that's going to scale out to billions of implications at a time? AWS is making a lot of strides towards a cell-based architecture. A lot of customers have like cell-based architecture. The beauty of that is that I can make a very tiny cell that I can easily stress test on my work macro for somewhere like in a dev environment. I can easily stress test this tiny cell, and then it's very easy to generalize. Okay, this is how well a cell performs, and then I've got 10 million cells in production, so I can like literally scale it 10 million times.
Yeah, and then I think, one of the key things definitely is when you are writing your code, you are actually, when you're running it, that's when you're making a determination whether, 128 gives me the best, or you're actually bump it up to 960, and that's when you get the best performance. And it's not always the largest amount of memory that's where you get the most bang for the buck.
Right, thank you. There's a question over there.
Hoping you could talk about those potential security issues or concerns and like best practices in regards to that service.
I think when you think about cloud security generally, like obviously AWS has a shared responsibility in a lot of most of you would probably very well or have security services up to OS in the case of the function. So you're able to leverage a lot of those best practices, and you're seeing us add additional like governance manifestations around Lambda, around some of these other serverless services, like Glue, like serverless Athena. So from a security best practice point of view, I think just applying the same best practices that you're running for your regular code deployments, making sure you're not passing secrets and keys into a public GitHub, private S3 buckets, the things that used to be easy to do in the GUI, where you could expose the S3 bucket, and we've seen customers run into that problem. We made it a lot harder now. It's like a big red bar that says, "You sure you want to make this thing public?" So kind of helping people in that regard, and then from securing your Lambdas from unauthorized invocations. So thinking about traditional security groups and understanding what's going to trigger your Lambda, so that folks can't kind of forward requests. Maybe you're using like Cogito and passing JWT. That's instantiate Lambda, or it's API calls or API gateway. You have multiple ways that you can really secure it end-to-end the way you would any other application.
Lambda actually has, in my mind, a really nice model for this because it takes the existing tools that we have in the form of security groups of IAM policies, and it breaks them down to really allow you to do policy at least access. You have these very granular, this very granular control over knowing just what your code needs to do and what it needs to talk to. So let's take just as an example how we run production and staging. We isolate them at the network level. They can't talk to each other. They can't even resolve DNS for each other, let alone open up a socket to each other. And that's something that we did on purpose. But what's nice about IAM is we can go one step further and say, not only do I separate these into different accounts, but I can actually break this up and say, I can have a namespace. I can have, and this is not really an IAM built-in, it's something that you have to layer on top using set governance. But I can say, you're allowed to talk to credential service star, or you're allowed to talk to management service star. Or maybe you're only allowed to talk to a specific set of functions because you know those specifically need to get called. You can go one step further and say, if I'm actually practicing a true segmented microservice environment, I've got data stores that are specific to my services. Why would I ever let another service talk to my data store or another service? Isolate them off, separate security groups. That's something that the AWS environment is really great at, in my mind, and that's where we see a lot of. I know folks are now doing this on top of Kubernetes. CNX is a product that aims to, among other things, they were selling to us that they could support PCI compliance on top of a Kubernetes cluster by doing that kind of isolation. There's now NSX on top of Kubernetes as well. This is really a new way of doing the same thing that we've been able to do elsewhere for a long time, but now much more powerful because we can be much more granular about it.
The only thing that I will add to this is that, if you're still extremely security conscious, you still want to have a complete separation of the environment, but you don't want to pay for the dedicated hardware, you might want to look at something like Firecracker. That still gives you a much better segregation in terms of all your resources, including the network layer and everything.
I just wanted to add a couple of very mechanical, tactical recommendations since you specifically mentioned Lambda. So Lambda is serverless. People like to make a lot of jokes about like, oh, there's still servers, but it is still executing code like on machine. So if you're doing something like taking a file name from an object that was put in S3, and then you're running, os.popen in Python with using that file name as part of one of the commands, people can throw in whatever they want. They can name the files however they want. And Orly Siegel has a really great presentation from this most recent Boston Serverless days, where he showed that you just like dump in basic form coded bash into the file name, and then when it goes to execute it, it executes the file name as a command, and then it's like dumping the Lambda code. So you might think, oh, well, I can hard code these credentials and not check them when they get hold of these. Put them into my Lambda function. No one else has access to my console, so they can't see my code. But if you're doing something like this, you could open up your code to the rest of the world, and then they can see your credentials, and they do like change type attacks. So these are things that it is serverless now. You don't have to own the servers. You don't have to manage the server yourself, but it's still running. Some computer scientists can tell me what the actual name for it is, but it's actually executing stuff on a machine that you still have to do the same things you're doing, which is sanitize your inputs, make sure characters are escaped properly, look for bad or what you would expect.
Something that's really nice about the offering that Amazon gives you is that you've got, as other managed offerings, we have SSM, we have KMS, we have ACM, we have all of these tools that are available to us and integrate really nicely with all of the other AWS offerings in order to enable you to make some of those otherwise production grade choices just right out of the box. You don't really need to think about where am I going to store my secrets. We have a managed service for that. You don't need to think about how am I going to go remember to renew my certificates. We have a service for that. If you want to go with the managed offering, then it's all available to you. You can just go start using it right out of the box.
Yeah, I mean, I think so I think that's a great point, because if you're in AWS and if you're writing something from scratch, you're not doing it justice to your company. You should look at what the AWS has to offer and use that as a.
There's a question over here before.
Is there a question? This is going to be tough.
It's soft.
Oh, I'm worried about something.
Okay, so earlier Ryan was talking about Lambdas, right? Full stack, industrial containers. So the way I see it is there can be two levels of containers too, right? One is the actual VM/container like Docker. The other one is the virtual machine that's required on the core. And two levels of containers. And in some cases, you may need to bring up both of them too to execute my Lambda function, right? I see, since we're talking about performance, I see these are not things that the developer controls, right? Is there a way, for example, like applying an auto-scaling concept to this, so that you can control the containers that are available for you ahead of time, so they're not running in full stack?
I would. I'm real big on the idea of don't use Lambda, which is weird being a serverless panel. I've seen a lot of examples. If you're trying to struggle with cold start, this is something that Amazon is constantly working to improve. I think it'll always be a problem. It'll always be noticeable to some degree or another. They can get it down to a single millisecond, and people will still be like, well, I'm using it for high frequency trading, it's below a millisecond, or whatever. I think that if you're spending time thinking about how to get around a cold start, it's probably like an architecture smell or design smell that you'd be surprised, like a lot of applications that where you just completely eliminate the Lambda and use like an event-driven architecture where one service just directly interacts with another one. This is not to say that there are no use cases for Lambda. I just think that right now it's been overused.
I think the one thing to add too is like in terms of the performance improvements for cold starts. Originally, Brian, you mentioned like runs in containers, which we don't want you to know. I think we've done a better job of kind of peeling back the onion, so to speak, and especially with Firecracker as like a micro VM that you can run locally in your development environments to be able to execute these Lambdas as well. So understanding the underpinnings of where your function is going to run and operate, and understanding what that time is to instantiate that function for like high frequency ones. So we had a serverless workshop in the Boston office with one of our partners in Ubiquity. So they built a reinvent mobile app, right? Which this year, to your point, we had 65,000 plus people all trying to book transportation on the next bus was going to the next hotel in the 13 that we were having sessions at. And it was all serverless. So they had a really interesting architecture presentation, case study with stuff on the website. So understanding that and from a cold start perspective, if you're operating at scale and you need some pre-warming, think about the heyday of ELVs when they were just classic load balancers and you could call up support. Brian's point, they can help you with pre-warming. There are some options there for customers as well when it comes to pre-warming for Lambdas. But to Rich's point, if you're that fundamentally worried, or if having that cold start for that first invocation means success or failure for your application, then there are other tools in the Amazon tool chest that are just as easy to build, maintain, and scale. And you should kind of consider the right tool for that job.
I'm going to say something a little bit heretical, pre-provision some capacity. And that's helped us immensely. If you look at the way that our platform works, it's almost, as you said, entirely asynchronous. We have for 6,000 plus customers, I think we're up to 8,000 actually, I need to take the mental model. For 8,000 plus customers, we actually have staggeringly few web servers. We're just talking to caches, we're batching out jobs. But when I click the button that says export CSV in the UI and batches out a job, I don't want to have to go wait for something to start up to go run my job. I want it to be already there. I want it to be able to scale up. And yes, we have the ability to go run zero instances, 0 containers. If there's no work to be done, then I don't have to run any infrastructure to do it. Why would I do that? But if I want to be able to serve that first request quickly, then why would I not have something there in front of it to be able to make that request savvy?
No, I think that's what I was going to say. I'm pre-warming, yeah.
So we talked a lot about Lambdas, but we didn't talk about Lambda deployments, right? What is the best practice, like Kennedy deployment, blue, green, or and Lambda versioning? How does that? If I have a website which is calling Lambda as a backend service, then what is the best way to make changes to my Lambda without impacting customers?
So I'm a big fan of the architecture I've been using is I will deploy I do blue-green on 2 separate accounts. So I will deploy my Lambda to actually let me back up a little bit. The idea of having like a development environment and like a testing environment, staging environment, and a prod environment is kind of like a relic of the days where the servers, where you had the testing, the staging, the prod server. That you have to be very careful about things you made. I'm trying to get people to think about like have an AWS account that has like some resources in it, maybe it's getting some production traffic, and then spin up. You already have a provision, or spin up a new AWS account with the version 2.0 of your service, your microservice. Do your integration testing against that to make sure that it works, and then use like some of the DNS load balancing tricks to move your traffic from the old AWS account to the new one via DNS entries or gateway endpoints or something like that with like weighted routing. So this way, like, it is blue-green, so you can like quickly move back if you notice a problem. You don't have to worry about it. Like if you try to do the same account, there's Lambda alias problem. There's a lot of places where these problems crop up where the tool's not there yet, and account service is a really nice provision.
Yeah, I completely agree that the whole idea of having data space production is definitely a relic of when you needed to have environments in order to manage capacity or manage separation. It is something that I'll admit we still do because it's something that's familiar to us. It's something that we know how very intimately to test, and that's why we continue to do it. What we've been looking at more recently, though, is turning that whole model on its head. And instead of saying that a change goes into an environment, we say that the change is the environment. What that means is that essentially as we promote changes, we're promoting entire environments. If you look at that in practice, it means that we have, rather than having the staging credential service, let's say, we have the credential service at get shy ABCD1234, DNS or load balancer, whatever have you points at that. Once we've made sure that that data pipeline, that path works, then we can start failing load over to it, and then we can back out if something bad happens. What's nice about that, though, is that we can have very easily end-to-end environments that no longer you have one dev, you have one state, you have one prod. Essentially, you have one prod, or really as many prods as you like if you're running multi-region, or you have maybe single tenancy requirements for different customers, and you have n many devs as n many changes you have.
So I think one of the few other things to keep in mind is that it also depends on your maturity and your level of comfort with what you are trying to do, right? We as a company are in a very early phases of our serverless journey, and we are actually figuring these things out. We're figuring out our CI/CD model, what is that we want to do, and a lot of these pieces are something that are quite a bit dependent on what your business needs are as well. You don't want to be testing in production, right? So some of those things you may not want to do in production, but again, it is something that you go through and you do it in a much more mature fashion once you have a much better understanding of your environment.
So in case of web application, let's say I'm using API gateway in front of Lambdas. API gateway has its own way of like creating different stages, right? Can it use that?
So I would ask why. So from your question, we asked about a web application and API gateway in front of that. Real quick aside, what are you allowed to do?
Serving web request or HTTP request.
I understand, but what's like the logic? So the one
it's calling, let's say it's calling the database, querying the data, and giving the data back.
So what I would say is have your API gateway directly talk to the database and just drop them in there. Right? And then you can enforce access control on some API gateway, enforce models, consistency, you can do some small error checking for really crazy inputs. Use like the IAM stuff or it's public stuff that I have questions on it, but like just the fewer things you can involve in this, the better. And like generally, when that is not needed, the API gateway can just directly query the database and pull the data out. If you're using like Dynamo or the serverless offerings, if you're using maybe like Aurora D8, it's a separate question. I would say I would not use the API gateway as a staging mechanism for that. Just because like you didn't get into like custom domain names or routed like multiple stages, I would just spin up a new instance of an API gateway that points to another Lambda that has access to the same backend data store, and then move your traffic via DNS. There was a question or something. That was you.
That was a good throw.
I was trying to deny it the camera.
It had happened before.
So I'm new to AWS Lambda and trying to learn more about it. I was wondering, it's a related question, I guess. What's the best way to handle dependencies for your AWS Lambda functions? And have you seen any trouble one way versus the other? Like, do you keep it on bare metal or do you like put it on S3 and so on? Yeah.
Yeah, I think the easiest way is really like when you think about SAM, like how to kind of build locally and have some of your lambdas there and kind of pull in those dependencies. It also depends on like what language you're writing your lambda in. So there's some really fun like new JavaScript stuff or with Amplify if you're building full applications
managed services. So from a dependency perspective, being able to use the Amplify CLI to build end-to-end application using Lambda, using Dynamo, using load balancers, et cetera, is pretty powerful. I'd say the other piece to remember, we talked a little bit about like the local storage. So thing to remember is you get 250 megs, and that's for your function plus any layers that you have. You do get 512 megs of like temp space on that Lambda itself. So if you need to load up some dependencies or like pull in another package, Python package or something like that from S3 or from another source, actually you can do that, load it up there, but that's also going to add to your cold start time, to your execution time, and things like that. So really see what you want your function to do, define it as tightly as possible, and try and load it as little as possible so it can execute quickly.
Yeah, I mean, I think that there are, if you look at AWS documentation, there are some really good practices. Like if you do Java development, jar files, you don't want to package everything in one single jar file because it does take much longer time to bootstrap the Lambdas, right? You do want to divide them into multiple smaller jars. And so there is definitely a number of different things that you can do as part of the deployment, and follow those best practices.
I think something that's helped us immensely there is just having a good CI process around our Lambda management. We use Jenkins as our CI engine. We're using heavily Jenkins pipeline, which is the thing where we put a Jenkins file in your repo and it goes to build it. What we're doing is we have pipeline libraries, and let's say that you have a Java Lambda or a Java-based Lambda you build using Maven. Your Jenkins file is import this pipeline library, Maven Lambda pipeline, bracket, and it goes. I might have a Scala one that builds with SVT. Cool, SVT Lambda pipeline, and it goes. We have Go Lambda pipeline, and it goes. We can enforce the best practices up and not require developers to think about that themselves. We can own that for them. The idea there is that we establish a contract by which we say, here's how this project might do dependency management. Here's a skeleton project or an archetype that you can go copy from. It's the best practice that we sort of work with. If you want to work within the sandbox, cool. You can get up and running in probably 15 or 20 minutes with a blank Lambda. If you don't, cool. You can do the automation yourself. If you want to reuse some of what we have, cool. You can do that too. All those pipelines break out. But really it comes down to, at least for us, how do we codify as much as we can so that you don't have to think about the best practice, you just get it out of the box.
What do you guys think of the serverless framework as opposed to using SAM templates? Because it kind of simplifies a lot of things for you, where you can use like a serverless module. And let's say, for example, if I'm building a Node.js app, you can just install a serverless module and have a Lambda and ETL gateway running without working on SAM templates or cloud permission templates.
I'll start. I mean, I think the choice for it is very easy. We started out with SAM template. When we last year, when we started looking at our serverless journey, we started out looking at how do we actually develop these Lambdas and how do we test them locally. A lot of the development lead and the developer, this is one of their biggest concern is, what is the tooling should I use? How do I actually, I was able to run everything in my local container, and I was able to run test, debug, unit test. How do I do all of that, right? And I think what we have found out is that so far, going down the journey of SAM templates, it has worked out for us. Again, it may or may not be as mature as serverless, but I think that definitely shows that AWS is actually fully committed in supporting a serverless model for an application. And I think it has done a pretty good job. I think you can not only run your Lambdas locally, you can actually debug them, attach to the other external AWS services as well. So it's pretty cool stuff. If you haven't checked it out, definitely check it out.
I'm going to answer the question. I'll throw it to you. With service, I started with just pure cloud permission back then when I was watching. I'm not learning SAM, and you can't make me I want to do it. Then I started using it, and this isn't so bad. And now I'm like, you're not going to make me use serverless. Maybe I'll get to the point where I start using it. But my biggest fear is that if I break something, if I can't get something to work in CloudFormation, I can call our technical account manager, I can call AWS support and say, like, my CloudFormation script doesn't work, it's not doing what I think it's doing, most people are dumb. And they're like, oh yeah, just like add this line here through a white space, CloudFormation white space, sorry, and it'll be fixed. Or they'll guide me through it, or I can file a bug, I can track that. And with like the amount of money the company spends, I can listen to sometimes. But with like serverless, I feel like because it's like a third-party company, I'm not bashing on serverless, it's like a great tool, a lot of people swear by it. But my fear is that like I'm just like another like faceless user of this, and they go like I don't know how to get this to work, and it's like I'm not quite sure where I go to get support for that. Sometimes it's like my own ignorance of not knowing that area. I'm trying to just like minimize the number of like tools that I can own, and I just kind of gravitate towards SAM and like one of my own like macros what I need.
Hey, okay, yeah. So back to the whole question about packaging your Lambdas. Usually I do it, I use the Python runtime and I do it in the CI/CD and I have requirement stacks. And if you install, the thing is that when you install off of the requirement stacks, you can easily load your package. So usually I have to do some manual workflow to try and figure out what exactly I need before I push this thing out there. So I guess I'm just trying to find out if you guys have any like strategies to go about doing this.
No, I just delete the requirements file, right, and then I slowly re-add requirements until it works again. It's a fun exercise to do once a week. But yeah, that's all I have. Like, I do the builds locally. It pulls in the requirements. I've seen a very common use case where someone has like a bunch of management functions and one requirements files. So what happens is all of your lambdas get the union of all of their requirements. So just splitting that out into separate requirements files per function, even though they're the same template, will like save you 30–40%.
And sometimes what we're enforcing is very similar to what we do for server applications, very similar to what we do for containers. Is our serverless functions live in their own repository. That obviates the fact that you need to have that requirements that attach to your Python code in there. Where else is it going to get it? What that really enables you to do, though, is think about what is this function actually doing? What is the minimum set of dependencies it needs? So we haven't gone as far as to be able to say these are your unused dependencies, but we can very quickly say that your Lambda, because of the monitoring and the sort of the management layer that we've got in place, that your Lambda is a standard deviation larger than everybody else's what's going on. So that is something that we should keep track of, is what are you doing with regards to everyone else? We almost have something, I won't exactly call it a leaderboard, but you can think of it like that. And we can say who's approving the most cost, whose Lambdas take the longest to build. Those sorts of metrics are things that we keep track of them, we gamify them a little bit, as much as you could say that we do that sort of thing.
Just one more thing that I'd like to add is I think these are all great strategies. But if you run into a problem where you know that your Lambda has a cold start, how do you know, right? How do you find out, it is not your code that's actually slow, it's actually the Lambda, right? Now, so if you look at the new service from AWS, it's called the X-Ray. Essentially, up until now, this whole Lambda startup time and everything was a black box for us, right? If you turn on X-Ray, it'll actually give you a breakdown of how long it actually took to start it up, how long it was actually your code that ran. So again, I think definitely look at that if you haven't checked it out. Have a question?
I just kind of on the framework choice question. One of the critical, the key thing is, it's a business decision whether you want to be hybrid cloud versus Amazon. Because SAM is Amazon only. One of the key features is serverless frameworks you can run with different clouds. That's one of the best. It needs to be a decision. And with SAM, we'll be using it. I think it's a good discussion for being native on one cloud because you get the best. Everyone's learning a lot. You make that decision. Using SAM locally, internally, we have a way of testing out the Lambdas locally using Docker. There's SAM local, a lot of tooling that's getting, it's growing very, very fast. The tooling on SAM, Lambdas. So that.
I have another question, and this is specific to running Lambdas on VPC. What are the advantages or disadvantages? Like, what do we get by running Lambdas on VPC?
Running a Lambda in VPC, you can guarantee that any network traffic to or from the Lambda goes to a security group. You can guarantee that it executes the things that are invoking it and things that interact with have to go through security groups, so you can do like network firewall like restrictions on that. VPC Lambda is sometimes required if you wanted to interact with a Redshift cluster. Some resources that have to live in the VPC. My best advice for Lambda to the VPC is just go. Try to not avoid it at all costs.
I think if it's a requirement, like if it's a legal requirement, that your data or your processing doesn't go outside your network, then it's a must-have, right?
I think that's the way that customers will leverage it. So when we're talking about security and compliance before, if you have that requirement, maybe it's a PCI requirement or some other requirement that you need to leverage, it's why it makes sense to execute Lambdas within your VPC. The other nice thing you can take advantage of, you mentioned some of the network tools, but also like services such as your RDB to really like monitor who's invoking, who's calling what, and apply some machine learning to that so you can understand if, if your e-commerce site and your storefront is all running Lambda code, you want to understand if you're under a heavy attack from like a botnet enforcing trying various passwords from a set of IPs. Having guard duty running against your VPC is going to give you some visibility there where if you're executing Lambdas outside of VPC, we have to get that from the log somewhere else Lambda was running right onto, and it might be too late to stop a potential attack like that. So I think you have some considerations there. Also just like the per VPC limits. So we talked about Lambda soft limits before around concurrent Lambdas that could be executed. There are hard limits for Lambdas in VPC, so like that's a consideration when you're thinking about your application of, is it a single VPC, is it multiple VPCs, a single AZ, is it multi-AZ with multiple VPCs in each AZ? Just when you're architecting your application, you have to think a little bit differently about that.
Something that we think about with that is performance. One of the things that we're looking into now, because when you consider what Cloud Health does, we reach out to customers' accounts and say, give me all the instances, give me all the volumes, give me all the AMIs, that sort of thing. We hammer the APIs on the Amazon site quite heavily. We can get significant performance gains out of using the private endpoints feature. We already get significant performance gains out of using private endpoint for I forget the term for it, but it's transfer acceleration for S3. That's only possible in VPC. Let's talk about data stores. We pretty heavily rely on Elasticache. We've got a couple of databases in RDS as well. Those are not things that you want traversing the internet. You don't want those exposed to the public world. Sure, your serverless framework might be stateless, but eventually in there is state somewhere. I would be willing to guess that at least 99% of the folks in this audience have a relational database working somewhere in your stack. Do you want that exposed to the outside world so that your serverless framework can hit it, or do you want to just keep it within your bounds?
So from performance point of view, is there a real difference or there's no difference at all?
Eventually it will. That's why I'm saying if you're architecting for scale, eventually it will.
Yeah, I mean, I think security is definitely a bigger concern, right? Is you're actually bounding your Lambda around the VPC boundaries, right? And I think that is a key thing when you're looking at it. If you want to access any resources within the VPC, you definitely want that Lambda.
All right. One more comment.
I think similar to the earlier question about Lambda and is it the right tool for the job when we're talking about that, I think this is the same question. If you have a security requirement and you run into those performance or scale issues with Lambda and VPC, so for instance, that architecture that I talked about with the serverless day for the event, that was all Lambda and VPC that powered it for all the attendees. So when you think about the concurrency and the scale of those Lambdas, maybe I reload all these devices talking to various Lambdas, like their scale is going to be a lot bigger than 65,000 attendees, a million different robots trying to communicate with various services. That might make a big difference also, depending on your app and your security requirements, then that might tip you into choosing container versus serverless or EC2.
Yeah, we do have VPCs, and there are some Lambdas that run VPC. That's almost always a last resort. That's either a regulatory requirement or there's literally no other way to do it. There's support to get AWS the list of them. Any questions?
One more question.
Sure.
All right, so in the introduction, Brian was talking about lambdas that call lambdas, and so on, right? So I'm an Alexa developer like Brian, and I built a like a transcoder that takes sound or voice and does like loudness sort of correction. So it takes, you know, stuff comes to one bucket, transcoder runs, and then it drops it to another bucket. And unfortunately, I did the configuration error, so I somehow created like infinite loop. You know, I racked up my free tier lambdas very quickly. You know, it runs us really, really quickly. So my question is, how do you debug problems in serverless environments?
Well, I think, first of all, one of the best practices in Lambda is not to recursively call another Lambda. Right. I think you found it by a hard.
I did, yes.
Yeah, and I think in terms of debugging, I think there are a few tools. First of all, you need to make sure you have run your Lambda code debugged in your local environment. You have your unit tests and integration tests executed. So the chances of having an issue leaking into your production environment is low. But you know, things happen. You know, that's the nature of the software business. Is essentially we will find some issues in production. And I think there are two tools that I think that are very, very helpful. Definitely one of them is CloudWatch, looking at the CloudWatch metrics, CloudWatch monitoring, logs. But I think the other things that I was actually at the reInvent game day, and this was one of the challenges that they gave us is essentially, you know, we're writing a Lambda and there is somebody attacking you. You got to find out what really happened, what happened in your service. And you have a service, you're calling one service to another service to another service. How do you find out? And the solution was turn on X-ray. It will give you a service map. It'll tell you that, yes, and throughout the whole service map, this Lambda is red, and that means it has an issue. You can actually double click on it, and it actually gives you the whole you know, details behind what's going on. So I think those are some of the tools that you have in your tool chest, and I think that's definitely would have helped you figure out this sooner.
For us, I think the broader question is, what does your observability framework look like? What tools do you have to enable tracing? What tools do you have in the absence of tracing to add it very quickly so that you don't have to take things down to do so? One of the biggest things that saved us, especially with the serverless environment that we run, is just having CloudTrail logs indexed so we can rapidly query them across different dimensions. We use sumo logic for that. I've done it with Splunk in the past. There are these tools where a dime a dozen let you do that, but they're very rich when you look at what really how an environment such as you build with Lambda works, because everything is an API call. All of that gets tracked. All of that is, you can more or less see what events are happening as they're happening just by turning on the live tail at one of those platforms. That's something that's helped us very much.
So I did this once before where I thought it was very clever. I needed to take all the data from one database and put it in a Dynamo. So I'm sorry, I take everything out of one Dynamo table and put it in another one. And I was like, oh, I'll just have a Lambda that scans it, and then when it's about to run out of time, it'll take a continuation key and call itself. And I was like, pat myself on the back how clever I was. And it did the same thing. It like took off. And that's when you also learn about the asynchronous implication, because I was calling asynchronously, is that you throttle your Lambda, so you say, okay, stop this Lambda, and it stops. And then when you turn it back on, say, okay, like now start again, it'll restart all those. Right. So you have to give it some amount of time that's not advertised, it's not documented, to let the asynchronous implication retry as kind of a timeout. We realize that like it's generally an anti-pattern for a Lambda to call itself. There are cases where you want a Lambda like a fan-out pattern to call other Lambdas, or maybe it's kind of like a reducing thing. But yeah, if you have a use case where Lambda needs to call itself, like wrapping that into a step function makes it a million times easier to trace. One of the biggest benefits of that is for logging purposes. So the logs are broken out by the container that it was executed in. So if you have one Lambda function that's calling itself, your logs will alternate between two entries in there. And that's not easy to figure out. But if you have it in a step function, it gives one Lambda time to exit, and then that container becomes available. So the next time you execute it, it executes in the same container. So you're not keeping these two containers warm and like trying to stitch logs together between two of them.
I was gonna agree, I think step functions is a good. The other thing is, we talked about the concurrency and the limits in terms of soft limit and raising it, but it's also a good best practice if you're kind of putting something out into the wild the first time to lower it.
Yes.
And say, hey, I don't want this thing to run away, especially if it's just
Yeah, I learned that hard way. Okay, any more questions? If not, thank you very much. And Brian.
So just thank you very much for the panel. If you have ideas for the next meetup or anyone at the meetup, we might have a nice pipeline of topics, right to be or Antonelli in the meetup group. Feel free to leave feedback in the meetup app, about this meeting or about any of the speakers, about things you would like. Anything else? Thanks for coming. This is the last.